Yes, no. Okay, so for tonight, what I had planned for us is the following. Last time we coded together a certain class with certain instances of it. Do you remember what that was? Do you remember what example of a class and object we did last time?
It was the book one.
It was the book one. Okay. And now, today I'm going to go over the lecture about how to code your own classes and methods. So this will be a little bit of review of what we did, but also some additional information. There's a lot of detail that goes with knowing how to do this. And then we're going to review together the book app from the chapter 4. I don't think we are going to hand code it, because I think it might be better use of your time to do the exercise at the end of the book, which will ask you to modify an existing class. And then the last exercise from the book is to create a class for a rectangle. And your first assignment was to create a rectangle program. So instead of using the starter code, I would like you to just use your own program, if you will, or start from scratch, but without looking at the starter code, and then convert this, or refactor is the proper word, refactor the program to calculate area to be a class, a rectangle class. And then you're going to have a rectangle class that calculates area and calculates perimeter. All right, so this will be the plan, and I think this will take us through the duration of the class, and maybe I would like one of you to show your solution to the rectangle and discuss a little bit further. So that's the plan. I think that's all there is I want to say. Okay. When we work with object-oriented programming, the first step usually is to design our classes. And so there is a really wonderful tool called UML, for Unified Modeling Language, that allows you to diagram your classes, among other things. Steve Conger teaches the UML in a lot more detail in his systems analysis class, so I won't talk too much about it, but I would like to show it to you in how you can use it for creating a diagram for your classes. If you're working on something like that, it's very helpful to start here instead of start coding immediately. So UML is going to have the class name up here, and then these are the fields and the methods. The fields are the data of the class, and the methods are the tasks that the class can do, right? So the convention here for UML is the following. If you have a minus, what that means is that the access is private. Like we created our data with private fields. And then you have the name of the field, and this is the type. So the type is added after column type. It flips them around a little bit. And then for the methods, the axis here is a plus, which you can guess means it's public. These are the methods. If it takes any arguments, it's going to put them inside the parens. And then the return type will be added after the column. Okay, so this is how you would write out a diagram for a class. And this uses, again, UML, which is Unified Modeling Language. There is a lot to UML. This is just a very brief introduction. So if you like, you can practice creating your rectangle class in this fashion. First, let's review the relationship between a class and objects. So what type of relationship do we have here? Well, we have one class, the product. So this is a class for generic product, and that's very helpful because you could define some generic properties that any class would have, or that any product would have rather, such as any product would have call, description, and price. And then you can create products, and you can also you can inherit from the product class and then create other more specific classes. For example, maybe you have, 3 different types of products: books, music CDs, and pens. Doesn't matter. But the point is that they will all have call, description, and price, and then there will be variation. Instead of having to call this in each one of your classes, you can just inherit and then reuse. So that's very powerful, and it's called inheritance. We'll do some examples with inheritance later. In this diagram, it shows us that from one class, which is like a template or a blueprint, you can create however many objects you need to. And this is powerful as well. You might just need to create 2 product objects. You may need to create 100, and it will work just the same. And what is the other difference between the class and the object that you see here? And do you notice anything else different?
The Tapman's parent one.
Say again?
So you say the questions are what different between product and young
Yes. Yes.
That was the parent product young his child.
Well,
That's
these are not classes, so the way this looks hierarchical, okay? Yes. But I wouldn't go too far with this analogy because usually what happens is from a product a class might inherit from it, not object. That's fine, but anything else that you notice in addition to what Piano said?
about
Do you see anything else different?
both of them are part of the product.
Both of them are instances of the product. That is definitely correct. Yes.
There's more specific than
They're more specific. That's one of the things I was looking for. They're more specific, and then what else? There is something else that is really I would like you to observe here.
In one you declare the type of the
Okay.
type, like the string, and now instead you write the variable.
So yes, so these variables will be of the same type. And what else? We're getting we're getting warmer and warmer. What else do you notice
one
about?
has the types and the other has the data?
Yes,
That's
so
what you're
the
looking
important, well, in my mind, what I was asking for was the objects have data, so they have a state associated with it because of the data, whereas the product, the class is generic. The class gives you the structure, but it doesn't have data. But the objects have data, and each object has its own unique data, which makes it so that it has its own unique state, right? The other thing that each object has that is unique is an address in memory, which we would call the identity. So the object has an identity and a state, the state being defined by the data that is specific to each object, right? But yet conforming to the structure of the class. So that's the idea with this diagram. I think that's all to point out here. So when we created the class, this is what we get. So there's a block of the class right now empty. And then with the product class, we have the instance variables. We made them private in the book as well. And then we access them through methods. Something I didn't point out last time that is pretty important is, in addition to protecting the state by not accessing directly, the other important part here is that this creates an example of encapsulation. So we can change implementations, and the outside world only needs to know how to call the method. If we change how we're implementing something or change the data, the outside world doesn't need to know that, and that's an example of encapsulation, right? Does this make sense? Okay, so that's also very powerful because if your code base changes, the outside world still will not be affected because they're calling the method, as long as you keep your method, what we call the method signature, the same. Okay. And then we have the constructor, as you recall from last time. So this is the default constructor, the getter and setter methods. And then the custom method down here to calculate the currency. Okay, so the rules for the syntax, for instance, variables. This is just this is not code, but it's just a syntax template, if you will. So if you see this or, this looks like a line, it's actually a logical or. And what it means, the way you'd read this would be, the access can be public or private. Then we can have a primitive type or a class name for the instance variable, and then we have to give it the variable name. In other words, the variable can be of double, but it can also be of a class, such as, we have done this actually, such as a string. But it can only be a class that you defined elsewhere. It can be your own class as well, right? So that's what this means. So this is your line to refer to as to what can be an instance variable. And then a couple examples here. So this is the Java class string, and this is a product class, which is a class we have defined. Nothing prevents us from creating instance variable with our own class. Question.
So I know that you said you wanted the instance variables to be private so that they can only be accessed through the method, but I guess what are the reasons why you don't want people to access the instances to change the types, or is that one of the reasons?
Well, they couldn't change the types. They could, if they're public, then you could go and change the content or the values from the outside. They couldn't actually go in and change the type.
Okay.
So, for example, what might be a reason? Let's say we have a credit card. I mean, you would not want to be able to access it from another program or from another class, just because it creates potential issues with the integrity of the data state of this class.
Okay.
That's how I would answer. Does it help?
Well, I guess since the instance variables are they're not actual values, right?
In here?
Yeah, they don't actually have values yet.
That's yes. Well,
So I guess I don't
right.
understand the credit card.
Well, but they will have when you instantiate it, then they're going to start holding values, and then when we have an instance of the object, it still has the same access modifier, right?
Okay.
So that's why maybe that's what you were
Okay.
looking to hear. And actually, they do have, when you call the constructor, that's when the values are assigned. So you're correct. Yeah. So when we start looking at it as an object, then that's when we are concerned with the actual values. That's a good point. Technically, you're more correct than what I said. Yeah. Okay. So typical code to where would the instance variables go? They usually will go up here. You can also put them down here. We'll probably stick with putting them up here. Constructors can be public or private. They always have the class name, and they have a list of parameters in square brackets. What is the meaning of square brackets when you read the syntax definition? It means these are optional. So in other words, you can have a class name. Let's say you have the product constructor. You can have it. Can you have it without any parameters? Yes, because the default constructor doesn't take any, for example. But then you can also have it with optionally as many parameters as the number of instance variables. Okay, so in other words, this is an optional parameter list that is part of the constructor. And this is here the 0 parameter constructor, where we set these values to empty string and 0. And I believe I mentioned last time, if we don't have a default constructor, Java still will use one when you create a class. So when you create an object, it will assign some default values, which are more or less the same. I think the string might be null instead of empty string. But they're pretty much zeros and nulls, even if Java created them for us. Here's the example with the 3 parameters. And also it shows 2 ways here to do the same thing. The first one is when the name of the argument or the parameter matches the name of the instance variable. The second is when it does not. So if we have the same names, we need to differentiate, the instance variables from the arguments that are coming in. And to do so, we use the this.code, which means this is the instance variable that belongs to the object. So the this keyword, the meaning of the this keyword is the one that belongs to the current object. And that's what we're doing here. Or you could just name them differently. And if you do so, you don't get to say this dot because now they're no longer the same. I prefer this method. And I think objectively that's a better way of specifying it, but you do have 2 options. Okay, and then methods, they can be public or private. They can have they must have a return type. So in Java, even if we're not returning anything, we still have to specify return type. So what is the keyword for return type if there is no one?
Void.
Void. So you'd have to say void, even if you're not returning anything by rule of the language. Or it can be the return type, string, and so on. If it has a return of different type, we would need to have a return statement in the method. And if you have a return statement and then you follow it with additional lines of code, what would happen with those additional lines of code after the return statement? They'll be ignored. So you don't want to put anything after the return, assuming it will run, because once the method returns the value, it leaves the scope of the method and goes back to the point in the program that called the method. Okay? All right, so these are the getter and setter methods, and then the method that returns a formatted string. How do we create an object? With a new keyword, and we can do it in one line or in 2 lines. The key is here that the new keyword is used. So you create, I guess I prefer this is more compact. You give it the class name, such as book or product. The variable name is equal to a new class name. And then if there is any arguments, you pass them here. So that's how you create a new instance of the object out of the class. And a couple examples with no arguments and with 3 arguments. How do you call a method? Use the dot notation to call a method on an object, such as product.print to console. And when you, in Eclipse, when you say, or in your own class, do you remember when I showed you say dot and then it shows some additional methods? Do you remember what I said they were? Anyone remember? Almost. So the additional methods you see would be because all classes in Java inherit from the top of the hierarchy, which is the object, and therefore all the object methods are available to all Java classes, and you see some of them in addition to the ones that you code it yourself. And if you have a method that returns a value, then you would need to store. If it's a primitive type, you need to store the value in a variable. So this is product.getPrice returns a double, therefore we're going to store the result in a double variable. This is a string. Okay, we're going to look at this code example together, but again, this is the static keyword. It seems like you guys have a good grasp of what that means now. Is this the case? Okay, great. And so you can have static fields or methods, as we know. And again, if it's static, you just call it on the class name. A couple words about the differences between primitive and reference types in terms of how Java handles them. If you have primitive types, and then you pass a value to a function, what happens is that what's inside a function is a copy of the variable. And so therefore, when you exit the function scope, the value of the original variable will not be changed. So it's called by copy. Whereas if you have something like an object, which is a product, those are passed what we call by reference. In objects, because they pass by reference, Java actually will make changes directly in the object itself. And so when you leave the method, if you made a change to an object, the change will be preserved outside of the program. So that's important to know, because those are different behaviors. Does this make sense? Right? So primitive types, you'd have to return it out of the function or you'd lose the change you made in the function. Whereas with objects, if you make a change and then use it later, the change will be preserved. And this is just how Java handles differently primitive versus object types. Okay, so let's take a look here. So increase price, pass it in a double. Price is equal price times 1.1. And now this is going to return, you have to return the price to get the change. Whereas if you have a product that you're passing in, when you set the price here will be changed, even though you're not using a return statement. You might want to return an object. I'm not saying you shouldn't, but if you just make a change in the function, the change will be reflected in your program, and that's important to know. And that's why you need to have an assignment here to get a return value, whereas you can just call the method and you don't need to have an assignment, even though you could. Okay, the last concept here is the concept of overloading methods. Has anyone heard of this before? In any case, we have actually seen a lot of overloaded methods when we looked at the definitions of methods in the Java library. Do you remember nextInt? Maybe we looked and there was a version that took no arguments, and then there was one that took one argument or two arguments, right? So when you use the same method, but you pass it different data types, so you can use the functionality and handle different data types, this is called method overloading. And that's a new concept for you tonight. So here are some examples. So print to console, you just might want to, print something to the console. It might be the case that you want to use a string separator to pass into the method, or you might just call it without any arguments passed in, or maybe you want to have a version that takes two parameters, string separator and string label. But it's the same method, but the signatures of the method, what we call signatures, are now different, because the signature is going to include the name of the method and the number of arguments it takes. Okay? So this is what we call method overloading. And it's pretty handy because you get to reuse, you're not reusing much here because that's a very simple example, but you get to reuse the functionality with different data types, because in Java you have to pay attention to data types, right? So method overloading, and we already know about this keyword. If you wanted to pass the current object to a method, you can do that by saying this, because this always means the current object. And we have an example here of the product class with overloading the methods. And this is what I have for the lecture. Do you have any questions? Did it help widen what we talked about last time, or? Okay. Well, let's look at the code sample. I think that, classes and objects, and then when we talk about inheritance, is very conceptual. So usually it's it might take some time for these new concepts to fuse properly. So that's the other thing I was telling, actually, the 1 p.m. section is that you might feel that why that doesn't seem very useful, or this seems so much setup for what purpose. Well, I am here to tell you that, I teach the Android class, and maybe some of you will take it. And the way that Android coding is done, it utilizes object-oriented programming to a high degree. So it's very useful, it turns out, to solve some somewhat, complex programming problems with the use of objects and abstract types and inheritance. So this is all really used there. And it's, in fact, if you don't know it, you'll be pretty lost. So
I forgot what's the Android class?
What is it? Or when?
What is the
It's ITC 162. That's the Introduction to Mobile Development.
it's not offered?
It should be offered in spring because you have to have this class for a prerequisite. All right, let's look at the code example from chapter 4.
Okay.
I'm going to import it here, but you might want to do the same. So let's see. Okay, I thought we would just run it and review the code, and then I'll let you work on the assignments from the book. I think that might be more useful because we already did one together last time. So let's run this example and see what it does. That's the book. So let's see. Picking up the wrong.
So we don't have our desktop, right?
You don't have your desktop?
Do we have the file in our file system that you imported?
Well, you do. You should. I mean, so for one, I have zipped it up. Again, there are usually problems downloading it, but you can try. This is a Eclipse archive file. If you didn't bring it on your flash drive, then go to Week. You should open it and look at it. It's going to be more helpful than just looking at it up here. So if you don't have it from another source, as you should, then you can download it from here. And then import it as an Eclipse archive. And that should work. I have asked you to bring those files on a flash drive to class every time. So that would be easier probably. Maybe I'll have one of you explain since we have already done. Do we have any volunteers? I guess you haven't looked at it, but I think you can still make sense of it. And I'll be here to help as well. Who would like to try walking what we would say we're doing a code walkthrough? So maybe you're taking over this program and then the other developer needs to explain to you what is happening here so you can take over the maintenance. So who is going to do the explanation? Anyone comfortable? Brian. You're at least looking at me, so I think that means that you just volunteered.
Sure.
And I know that I'm putting you on the spot a bit, but you want to come up here? Or? And the rest of you? So Brian is handing over the code to you, so you ask questions now, because then Brian is moving on to Google or someone else.
Yeah, I'll probably just ignore you. So first thing I did is created my product class, set my strings that I'm going to use. I use a string for code, and another string for description, and a double name price. Then here's my constructor product, and I set its initial values, and then moved on down to first. What is it? The word I'm looking for.
Custom.
Thank you. That's it. Where I set my initial values. Yeah. Oh no. So this is my custom where I did my where I passed these dudes down here, and then our setters, and then way at the bottom, our method. Where setting my format currency, and then also looks like another format for the price, and returning the price formatted back into the object.
Okay, there's more files here.
Yeah, I just want to do that
All right. Okay. How about I'll do the DB. Thank you. I'm trying to run it, and it's running the other. It's running the hello world, even though I deleted it, so that's frustrating. Do you have any questions for Brian? All right. Oh, I know. Okay. Okay, so the code, the project that we are looking at is going to ask you to enter product code down here. You probably can't see it very well. And I'm going to say Java. And then based on the product code, it's going to return to me the code name, the description name, and the price. And then we can do all this fun again, but I'll just say no. And then it will exit. And so the definition for the class was in the class that Brian overview. The program also uses a class called productDB, which tries to act a little bit like it's a database. It's not a database, but just approximating database in the sense that we are going to pass a product code to the getProduct method. And then based on the product code, we're going to do conditional statements to set different values for the description and the price. All right. And also note that it's perfectly okay if you need to, you can create an instance of the other object here. So this is an example where we're creating an instance of the product class so that then we can use its methods from within the DB class. The other thing to note right now is that the getProduct is set as a static class, a static method rather. So we should be able to call it directly on the product. All right, so again, we set the product code, and then depending on the product code, we're going to set different values. And what we're supporting right now is Java, JSP, MySQL. These are the 3 books we have, and otherwise the description will be set to unknown, and the price will not be changed, so it will be still 0. So that's the database class. Any questions here? And then we have the product app, which contains the main. So as we discussed, we signified that it contains the main by adding the app here to the title. Welcome to the product viewer. And so what we do here is we actually ask the user to enter the product code. And then we set it into a product code variable, which we in turn pass to the getProduct method of the productDB class I just showed you. Do you see how this all connects now? Okay. And then after that, after we have set the product code, then we can just display the information about the particular product with the product code that we set. That's why when I said Java here, it gave me Moorish Java Programming 5750. And if you look here, you can see that Java was set to Moorish Java 5750. And if I run this again, since I said no, and enter JavaScript, what should I expect to see?
None.
Unknown and price of 0, and so on. JSP, it's giving us JSP and the price. And then that's it, but I think it illustrates quite a lot. So it showed you how you can connect an instance variable with user input, for example. This might be necessary. And use a mock database class, use multiple classes. Any questions?
So instead of doing like the if statement and doing all the different, where we defined all the different values, can we just create different objects and reference those objects?
Yeah, we certainly can. And that's,
yeah. Doing it as defining them in there.
We absolutely could. And that's one thing that seems to be in fact confusing sometimes is you can do things more than one way. There is a little bit of design going into this. So you can design it maybe differently, but yeah, you could create an object for Java product and JSP and so on.
And then you just call that object when you enter that.
That's right. That's like we did with the book implementation.
That's
You could
exactly what
certainly, that's right. So you could do that. This is just showing you something a little different. All right. So if that's, if there are no other questions, let's take our first and only 10-minute break. And then when we come back, I will show you some suggestions as to what to work on in the lab time of the class. And I think I will turn off the recording since we don't have lecture material. And maybe I will say for those of you who are watching the recording, we are about to do, let's see here. We are about to do page 129, exercise 4-1, and exercise 4-2, except for 4-2, I'd like you to not use the starter code, but just do the area and perimeter from scratch.